Okay, yeah, you're welcome back to the second part of today's session. Um, Pardon me, I'll just have to reshare my screen so that we can view everything. All right, I believe you can see my screen right now. And I want to stop transcribe. I'm not a fan of transcribe because I say something and the transcribe says something else. That's fine. All right, so yeah, so this second half, we will be looking at AI for good and the position of AI in the world. You all will agree with me that AI is becoming part of our daily lives, whether we want it or not, but it's making our life, it's simplifying the way we live, the way we relate, the way we react to things, the way we even travel in different aspect of our lives. AI is showing up day in, day out. So this presentation slides was produced by Dr. Ian Rice, and I will be presenting this to you this morning. So let's move on. So we have different types of AI. I know some of you might not be aware of this. We have different types of AI, but for the purpose of definition, so what is AI? What is artificial intelligence? Artificial intelligence is a branch of computer science that concerns with replicating human intelligence in machines so that machines can perform tasks that typically require human intelligence, the use of our senses, our brains. So, for example, planning, learning, reasoning, problem solving, as well as decision making process. So that simply put is a good definition of AI. So we have different types of AI. We have the artificial narrow intelligence. It is abbreviated as ANI. What is the artificial narrow intelligence? That is what we will be delving in critically in today's presentation. We also have artificial general intelligence and we have the artificial super intelligence. So the artificial narrow intelligence is um, having to ask a machine or program a machine to be able to carry out a specific task. So it's a directed task. So that is why it is being referred to as narrow. So it's a directed task. Whereas on the other side, the general intelligence is where we are asking, or when the robot or the machine has intelligence as that could be equated to that of human. The narrow intelligence is not as intelligent as the human, but the general intelligence is as intelligent as the human, sometimes even more intelligent than the human. And the third type of artificial intelligence, which is a super intelligence, is the one that is even more intelligent than the most intelligent human being. We are not there yet. In fact, we are not even at the stage of the AGI yet. We are still working with narrow intelligence, as it were. So in recent times, you have iPhone imputing some machine learning applications in the phone that can help the phone to function better than it used to be. So the AI, as I have mentioned in the last slide, is where machines is being programmed in order to perform tasks that human will have performed. So this is what AI is. And in the recent times, we have seen different organizations using AI in different form, in different tasks, in different areas. So we also have what we call the machine learning or ML. Machine learning is not the same as AI, but is a subset of AI. But most times, artificial intelligence use machine learning models and tools to um, complete tasks. That having said, doesn't mean that machine learning is the only aspect of AI that could be used mathematically to solve problems. We also have what we have engineering robotics, which is not part of machine learning. But machine learning is very critical to artificial intelligence. These are functions that we write programmatically to solve problems and to have to be able to view patterns, to be able to have insight when you look at your data and you apply some either supervised learning or unsupervised learning. Don't bother yourself about what supervised learning or unsupervised learning is all about. Even though I'm going to be talking about supervised and unsupervised learning, it's part of machine learning. So this is where you apply, these types of models or techniques, as you want to call it, to your data in order to find some critical information from the data. For example, you have an employee data and you want to find out how many employees have taken have been off sick in the last first quarter of the year. So all you need to do is to download a data that is correspondent to employee taking sick leave. So you are able to classify those who have taken maybe sick leave for more than 10 days, 5 days, or 2 days, as the case may be. So you write a program and you're able to get this information. Then the third part is what a part of AI that is very, very popular these days, and it is called the deep learning or DL. What deep learning does is solving problems in hierarchical form. So you have different models trying to solve problem, but this is done in hierarchical form. So a particular problem is being solved at a lower level, then it goes on to a higher level and another level, just the way it's closer to human brain, how we solve problems in real life. You want to get into a building, you first of all go through the main door, then you decide which of the area you want to go to, maybe the ground floor or the first floor. Then when you get to the first floor, you need to locate the particular room you want to go to. Then when you get to the room, you want to locate where exactly which part of the room you want to go to. So it's hierarchical in nature, and that is how the deep learning function. It functions in different layers, learning from themselves, really. So that is more in-depth. As you go along, for those of you who will be joining the course in September, you will be making use of machine learning and you will be doing lots of deep learning. In fact, deep learning is a model on itself. It's a whole model on itself, as well as machine learning. They are models in themselves. So you will be delving into machine learning as well as deep learning on the course. So like I said, I mentioned supervised and unsupervised learning. What is supervised learning? What is unsupervised learning? An example of unsupervised learning is clustering. You want to cluster things into where they belong. For the fact that it is not, you don't have a prior knowledge of what they are, or the machine does not have a prior knowledge of what will be clustered. So it is unsupervised. So you want to cluster, for example, into colors, like you can see on the screen. You can see where you have the purple, the red, the green, automatically they fall into place where they belong. It's just as if you're in a room and you're clustering people according to their, how do I put it? Or you want to cluster animals. So maybe amphibians or carnivores and stuff like that. The fact that it is not, there is no pre-knowledge of what you're doing, as in the case of supervised learning, then it falls between unsupervised learning. On the flip side, the supervised learning is where you already know what you want to do, the result you want to get. An example of this is classification. Classification is an example of supervised learning. Don't know why my just a minute. Don't know why my it, okay, oh finally. Okay, so supervised learning on the flip side is where you already know exactly what you want to get. An example of this in artificial intelligence is a self-driving car. The self-driving car, you put things before you write algorithm to show what you want the car to do. You're telling the car this purple part is the road, and this is where you should travel on. So you have specified the road to the car. So when you see green objects moving, those are human beings. Don't run into them. You have specified that. The yellow are the poles. Don't run into them. But having said that, you can see that the zebra crossing is not really defined. And these are the different lapses that we still have in artificial intelligence. You could see the zebra crossing is not highlighted in a particular color. So what that means is that the car will not probably stop at the zebra crossing because it's not showing, it's not specifying. Then again, if you look towards the far right of the pictures, you will see some orange patches. Of course, orange is supposed to be another car. Don't run into another car. But the footwear of human beings is being color coded as orange. So this in itself is a downside. So we still have some things that are not perfect, and that is why it's not the AI is not a general intelligence or super intelligence yet. There are still some errors that could be found, and that is why sometimes the self-driving cars could be biased. It could be biased, not getting the right formation of its environment correctly, which of course could lead to accident. I don't know how many of you have heard a self-driving car in Europe that had a fatal accident. This is part of the downside, and of course, the programmer will need to go back to the drawing board and do more work. So yes, again, we have prediction. Prediction is another supervised learning. You want to predict based on what you have historical data. So you feed your model with training data and you test it with the sample data to see whether these are correct, how accurate that is. We talked about learning, deep learning. This is an example of deep learning. Deep learning, as you can see, this image is at the right corner of the screen. So we have the image recognition model that uses deep learning. Remember, we talk about different layer, hierarchical way of the detecting or completing a task. So you will see that there is an understanding whereby the different level is being shown until there is a defined object. The left-hand side is the facial recognition of human being. So what it does is that it narrows it down and be able to dictate what exactly the picture is. So it's a traditional machine learning layer that look for specific features in order to be able to classify a human face and depict it from or distinguish it from a face of an animal or a cat or dog, as the case may be, using sequent layers of pictures. So the other side is a car. You can see maybe you want to just look at car generally, or you want your model to specify whether it is a family car, a truck, a heavy moving vehicle, and so on and so forth. Like I said, you will be delving into deep learning when for those who will be coming on the course. So again, if you're comfortable putting your question in the chat box, please go ahead and do so, and I'll be looking at it before I wrap up this session. So what can AI do? Or some people may ask, what can AI unable to do? Or in this case, I want to see what AI can do or what AI can do well. One thing I want you to know is that AI is very good at being subjective. It has this tendency of subjective discrimination. AI discriminates because it is the way it learns. And when AI learns something, if it sees something that has not been learned, then it kind of discriminate. And an example of that is the self-driving car that I made in a couple of slides ago, where the car might not be able to recognize all the different elements on its path. And what happens is if it cannot detect a particular element, then it becomes a problem. It becomes a threat to humans. And another way AI could discriminate is by way of not probably deciding exactly who is in a particular picture. But the good side of AI is predictive healthcare system. Ian Rice did a project with the Birmingham Children's Hospital some few years ago, where he was able to develop a model for the doctors. And what this model does is you can see a wireless patch on this baby. So this is to detect the babies that are very sick and the ones that are not very sick. And what this does is to be able to prioritize healthcare system or healthcare delivery in these children, so that those that are not very sick will free up the space in the hospital and they could be treated at home. And those who are sickest could have prioritized healthcare attention. So this particular project was quite successful, and the model, I believe, is still being used at the Children's Hospital to date. In cybersecurity, we also use AI. AI is, like I said, is infiltrating different aspects of our lives. So if you are interested in cybersecurity, when you come to your BCU, for those who will be coming again in September, we have fantastic team dealing with cybersecurity. You can always talk to them and see where, if you're for those of you who are interested in cybersecurity, you can talk to them and you can see how you can apply AI into cybersecurity space. So we also make use of AI for personalized insurance. We know that the insurance will not generalize premium. So the premium you will pay as a smoker and as a non-smoker is not the same thing. The premium you will pay as someone who is a bit sickly is not the same that you will pay for someone who is very fit and energetic. So AI will help this insurance company to predict how they vary their premium for their customers. So even though in those days they will say, okay, the older you are, the more money you pay. Sometimes now it's not just about your age. Some people are older, but they're elder than their younger counterpart. So all of different area that will be considered will show whether you pay more or whether you pay less than someone who is of the same age or the same gender as yourself. I have a question here. Let me quickly check this question. Please pardon me. How can interpretability and explainability be achieved in deep learning model, especially when dealing with complex and high-dimensional data? Thanks for the question. So this question is deep. It's not what you can explain and you get answer to as just with few sentences. So you have in recent time, I have a PhD student that I was an internal examiner on, and I think our work has got to do with explainability AI. It goes beyond that in blockchain systems or something. So it goes beyond that. It's more complex than you just explaining. First of all, you need to consider, you talk about the high dimensional data. These are data that are not 2D, they are multifaceted, they are multidimensional because you need to look at it's like a tensor where you have a box and there are lots of different things in the box that you need to consider before you can apply deep learning model into them. And like I said, deep learning model is all about using a hierarchical format to deal with problems. So you need to slice up the different layers in order to get what is going on and be able to predict or be able to get answers to your question. So interpretability and explainability is a deep concept of deep learning that is not what you can just explain away within a few minutes. It's quite deep. Deep learning itself is not just like any other machine learning that you just apply straightforward, but it goes beyond that. It's quite deep. But like I said, I can point you to text that you can read up for you to have a good understanding of interpretability and explainability of deep learning models. So we move on. I need to get back to my slide. 1 minute. Okay, so yes, we were talking about personalized insurance. So personalized insurance, you use AI to predict who pay more and who pay less when you are charging premium with your customers. So what about an election? Do you think AI can predict election? I don't know how many of you, it's a question that some people will say yes or maybe no, but I don't know how many of you heard about what happened some time ago about Facebook. Facebook and another organization where the profile of users were kind of filtered out. So it was filtered out, and they use it to push messages to these people, and they use it to kind of twist them into voting for a particular set of people. I'm sure you know the organization that I'm talking about. Is it Google? Why did I forget? So these were, they want to feel your pulse. So who are the people in your network? So when they push up a particular message to you, they're looking at your network gets to see it because they look at your profile, and there are some people, if they know you are pro to a particular candidate, they will tailor the message they send to you. And if you're anti, they know the message they sent to you. All of this was done due to the fact that they are able to get their profile, they know who they are, they know what they do, and they know what really will kind of interest them. So this is like what you say, even in the case of marketing, when you're selling things, you don't want to, in those days, people go to anywhere to just sell things to people. But the fact is that most of the time they waste time with the wrong people. But these days we have what is called the digital marketing. And digital marketing is able to target the right audience. They target the right audience. I don't know what's wrong with my slide. I hope I'm not missing anything. They target the right audience, and Again, I think it's over. I'm supposed to stop at 12, but having said that, I think something is missing. But I'll continue. I just want to put this to you before we leave. Apart from elections, we also have recommendation system. And a good example for recommendation system is Netflix, YouTube videos. When you watch a particular film and there is a similar film or actors that acted in the film that you liked is featured in another film, a new film, you tend to get notification, or they tend to sell that film, the new film to you, because you have seen a film that casted the same set of or similar actors and actresses. So these are what they do in order to kind of feature, to sell things to you. Again, remember the facial recognition we talked about initially, where the faces of people are captured and they're able to tag the people because they already have their profile on social media. And for those ones that are not on social media, you will see that even though the face was recognized as human face, but there will not be name to it. And they can use that to sell the platform to them, knowing fully well that they are not on the platform. That is why the face could not be tagged. So they could, I mean, sell the platform to them. Well, we recognize that you're not on this platform, but your friends are on this platform. You want to join in order to have a good network and so on and so forth. So these are different ways where you can use artificial intelligence effectively and efficiently. But having said that, I'm not going to say that artificial intelligence is a perfect system. It's not a perfect system. And that is where we bring up the impact of AI on the course, in order for you to understand the different impact that AI do have on different domain and different systems. Remember the one that I've just talked about AI being subjective, discriminatory. Sometimes you see a picture of a particular person and is being tagged wrongly. Just it is because, it's not really learning well. I told you sometime during this presentation that I don't like transcribing when I'm recording. And this is because the possibility that it is there that my diction is not well captured, and the system is transcribing different to what I'm saying. So rather than having that frustration, I always switch off my transcribe. I'm not going to fool myself. And something when you talk to Siri, you talk to Alexa, because of your diction, it might not really capture what you have said. So those are the different part of discrimination of in AI systems, which of course people like yourself, myself, will still work on that and make sure that in the future, no matter what your dictions are, no matter what your background is, as soon as you speak a particular language, the assistant, the Google Assistant, the chat box that you're talking to will be able to recognize your diction and will be able to give you accurate information that you require. So having said that, I have come to the end of this second segment of today's session. So I am open to questions now. We have enough time for questions. So please keep your questions coming. This question says, because AI voice recognition is biased towards Queen's English. Exactly, you're right. Yes, it's biased towards Queen's English. And if you're not speaking Queen's English, I don't understand what you've said. And it could be frustrating sometimes. Yeah, you're right. Let's see any other question. Let's see. Yes, notice that many times on Siri. Yeah, Siri would say, I don't understand. Sometimes I have to give the phone to my children to help me speak to Siri because Siri does not understand my English. Yeah. What other things do you notice in the AI systems? Is there any other thing you have? There is a situation whereby there is a picture of a black man and a white man, and when Twitter want to portray, I mean, show the image, they cut off the black man because they said the system was looking for a more important of them, of the two pictures, and cut out the black picture and replace it with the white one because it sees that white picture, the white man's picture, as a more important one that to the black man picture. So these are the different discrimination that we see on AI systems. Um, so this one says, because AI voice recognition is biased towards going to say, okay, due to overemphasis on these accents, right? Yeah, yeah. Sometimes when my colleagues that are British are talking and they say words like, let's say, a however, if I want to say ever, I would just say however. But my colleague would say however. It's like, yeah, because I want to draw your attention to the next sentence, but I don't have the time to do that. So it's kind of my sentence is off. Yeah, we understand that. But the fact is that we need to build systems that will not be discriminatory to people that are using it, because the fact is that everybody is using the system, so it should not be discriminatory. There any other questions or input? I'm very happy to read your input. So somebody else says, how can AI systems be designed to take into account cultural, social, and textual differences to avoid making decisions that might be insensitive or inappropriate in certain contexts? Sylvester, that is a very good question, but do you know what? You can't be one of those people that will build that system. Not that it's not being built. We've seen so many people transcribing um, um, in natural language processing using different languages like Mandarin, like other languages. So you can build. I could remember one of my students then said he wanted to use a Yoruba language for to want to use Yoruba language for natural language processing. So we cannot say how. It's the question should be when. So, and you can do that. You can do that. It's all about you getting enough dictionary in that particular language or in that particular diction. I know of some chat box now. I think there was a time I was just playing around with Watson chat box. I think Watson was owned by IBM or Microsoft. I've forgotten. I think IBM. Yeah, I was playing around with Watson. And of course, when you're doing engineering, you're putting in possible questions that could be asked, that you can put it in any way. But these days we find that I did it as well, putting in some elements of pidgin language or broken English into the system, so that when you say something like, I mean, for those who are not from Africa, apologies. When you say something like, are you day? How you day means how are you in broken English. So the system will recognize that as being how are you and will give you a response rather than saying that I do not understand that. Sylvester, I hope I've been able to answer your question. Another question here. What section, what sector, such as education or health system, are lacking in AI? Well, you cannot say that health system is not lacking in AI. There are a lot of medical AI that is being used in hospital. And an example of that is Ian's work that I spoke about in my presentation. And of course, we have lots and lots of cancer detection with the use of AI. How MRI is being read. You use AI to detect cancer cells in human being, and we've seen good percentage of accuracy. And one thing about medical AI is that you're not looking for accuracy all the time. You want to look at recall. Recall is where how many of these images can you detect? So the more you can dictate and you give it to a human doctor, if they now do their analysis and found out that, oh, there is no cancer cell, there's no problem, it's better than missing a cancer cell altogether. So that is why recall is more important than accuracy. But in a situation where accuracy take precedence over recall, an example of that is when you're trying to profile an offender. If you're trying to profile an offender, someone who has offended before, and you see someone who fit into that person's profile, and you miss how do I put it? You miss point out the person. So you need accuracy in that than recall, because you don't want to arrest the wrong person, because, I mean, the person can sue, the person can go to court and stuff like that. The person can sue for damages. So accuracy is more important when you're detecting crime than when you are trying to dictate a disease in medical terms. Social, yes, there are lots of work that is being done in social media analysis, but more could be done. I personally did a lot of work on social media analysis using machine learning, using data mining technique, which is part of machine learning. Yes, there are a lot of work. How can you predict a football match based on historical data? All of these is in the sports sphere. Also, AI is being used day by day. For those of you who watch football or watch any other sports, these days, you see a match that has not been played, but you can predict that this particular match, this particular side will win, because based on their historical number of wins, based on the type of player they are using for the particular match, and so on and so forth. Yes, there are different areas that AI is being used. Culturally, I can't say that AI has been really explored in different culture. So yes, we need to do more in that aspect. Let's see another question. It says, this one says, education. You say what the part that education, AI also is being used in education. But like I said, you cannot say that a particular domain is being is saturated. No, you cannot say that you have had enough work on this particular domain. No, we keep learning every day. Things come up every day, and more needed to be done from time to time. Can AI make mathematical conjecture? Yes, it can. In fact, AI is machine learning make use of lots and lots of mathematical conjectures, because there is no way you can make use of machine learning without considering mathematics. There is no way you can build an algorithm in deep learning without considering mathematics. So it's all about creating algorithm, creating functions that you can use to determine what you do the next time. So AI models can be specified as a parameterized mathematical construct, where you can write maths functions and for it, and to be able to solve different problems. Yes, it does have mathematical construct. Let's see, do we have any other question? Let's see the time. It's 12:15. The next session is for 2 o'clock. So you have a long lunch break, but I'll still be here. I'll be here till about 12:30. I'll be here till about 12:30. So for those of you who doesn't have any question, please feel free to exit and come back at 2 p.m. for the Python and Introduction to Data Science session. So for those of you who want to ask questions, please stay back and I will answer your question, and we can all go for lunch break at 12:30 p.m. For those who want to exit at this time, I want to say a very big thank you. I appreciate your time, and I hope you will still stick around till after till we finish today's session, and we'll see you again tomorrow and next tomorrow and Thursday till the end of this hackathon. We will try as much as possible to make it worth your while. So I'm going to stop recording now. Thank you very much.